So this is using the Pythagorean theorem to determine the length of a hypotenuse of a right triangle. So before we move forward, there are a couple things you need to know. The Pythagorean theorem, hopefully you have done the proof experiment and watched the proof video. However, I'd like to remind you that the Pythagorean theorem states that for any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So it's listed as a squared plus b squared is equal to c squared. A right triangle is any triangle with a 90-degree internal angle. It is usually shown by a little square. That means that that little area is 90 degrees. Legs are the sides of a triangle, and these are the adjacent sides around the 90-degree angle. So this would be, this here is A, and this here is B. These are the adjacent legs to the 90-degree angle. And the hypotenuse is C, and that is the leg across from the 90-degree angle. So if we see this 90-degree angle and we go across from it, that's going to be our hypotenuse, which is always C. So how do we find the sides? These are the steps. So we need to determine the legs, A and B, and the order does not matter. So the first thing I want to do is when I see this triangle, I'm going to look for that little 90-degree marker or something that shows me is 90 degrees. I'm going to go across from that 90 degrees, and that's the hypotenuse, that is C. The other two legs, does not matter which is A and which is B. I'm just going to make this one here A and this one here B. Next thing we need to do is we need to square A. Remember that squaring means to multiply by itself, so I determined that 3 is A. So what I'm going to do is I'm going to do 3 squared, which is equal to 9. Our next step is to square B. So I'm going to do B, which is 4 squared. Remember, we're multiplying it by ourselves, so 4 times 4 is 16. Our next step is to find the sum. That means to add A squared and B squared. So I'm going to add 9 plus 16. And from there, I'm going to get 25. And then our last step is to take the square root of the sum. So why do we have to do this? Because when we have A squared plus B squared, that gets us C squared. But what we want to find is C, not C squared. So remember that the square root is the opposite of square, so that's going to cancel out that square there. So in this case, we're going to take the square root of 25, and in this case, we get 5. So we know that C is going to be equal to 5. Let's try another example here. So now we need to determine the legs A and B. So first thing we want to do is look for that 90-degree angle. It may not always be in that bottom left corner. In this case, we looked at again. So we know that across from that 90-degree angle is the hypotenuse, that is C. So we make the other legs A and B. Again, it does not matter which is A, which is B. All right, so next thing we need to do is I'm going to write it as the formula this time. So we have A squared plus B squared is equal to C squared. So I'm going to do is I'm going to write in 5 squared plus 12 squared is equal to C squared. And now I'm going to find these squares. So we have 5 squared, which is 25. We have 12 squared, which is 144. And that's going to be equal to C squared. So now we just need to add 25 and 144. That's going to get us 169. So now we have 169 is equal to C squared. Now remember that in order to find C, we need to take the square root of this. And the square root of 169 is 13. So we get that 13 is equal to C. So that means that this hypotenuse over here is 13. Alrighty, right here, we are going to again look for that 90-degree angle right here. Across that 90-degree angle is the hypotenuse, which is C. So we're just going to make these other legs A and B. Again, it does not matter which leg is which. So we have, I'm going to write A squared plus B squared is equal to C squared. Now I'm going to plug in A and B. So our A is 8, so we're going to have 8 squared plus our B, which is 15. 15 squared is equal to C squared. So we have 8 squared, which is 64. 15 squared, which is 225. and those are equal to c squared. So now we need to add those. And so we get 64, plus 225. Plus 225 is equal to 289. And 289 is going to be equal to our c squared. And so in order to determine what c is, we need to take the square root of that because it's going to cancel out that squared. And we're going to get that c is equal to 17. So our hypotenuse is going to have a length of 17. Alrighty, now in this last case here, we're going to have something that's not going to be a perfect square, and this is where your reducing radicals is going to come in. Okay, so we're looking for that 90-degree angle. Across from that 90-degree angle is the hypotenuse. So we're going to make the other legs a and b. We have a squared plus b squared is equal to c squared. So we're going to plug in 10 for a. So we have 10 squared plus our b, which is 8. 8 squared is equal to c squared. 10 squared is 100. Plus 8 squared, which is 64. It's going to be equal to c squared. 100 plus 64 is 164. Not too bad there. That's going to be equal to c squared. What we need to do is we need to take the square root of 164. Now 164 is not a perfect square, so what we need to do is remember doing the prime factorization in order to find the reduced radical. So I'm going to do 164. I notice that its ones place is an even number, which means that it is also even, which means it can be divided by 2. So we have 2 over here. 164 divided by 2 is going to be 82. This one can continue. 82 is also an even number, so we can divide that by 2 as well. So we have 2, 41. All of these are prime. So we have 2 2's. So if we write this out, it would be 2 squared times 41. This 2 squared square root can come out because those cancel out. 41 cannot. So c is going to be equal to 2 root 41. So it is possible if you don't get a perfect square for c or for the hypotenuse that what you need to do is determine the most reduced radical. So in this case, c would be equal to 2 root 41. And there you have it.